As a teacher, you will appreciate how exciting and engaging the topic of fireworks is. But how can you bring fireworks into the classroom safely? Well, here on Teachers TV, we'll show you how. We've come to Chew Valley School in Bristol, and I'm going to be showing some experiments to a willing guinea pig, science teacher Trevor Thorley. He's going to have to watch carefully because I'm going to pick some of the experiments for him to perform for the very first time. So let's get straight to the experiments. OK, Trevor, so our first demonstration here is to do with oxygen, and I'm sure you're familiar with the burning spill, and the glowing spill going into oxygen. Let's just have a look at that. OK.
And we...
Beautiful. OK, so it really aids that combustion, doesn't it? Well, what now if you put a burning one into oxygen? Let's have a look at that.
Quite burning. Into the oxygen.
Into the oxygen. Really intense burn there. And by controlling how quickly materials burn, we can have really high energy release and really sort of gentle energy release as well. But we also use it with metals. By changing the amount of oxidising agent available to a metal, we can get the metal to oxidise really quickly or very slowly, depending on what we want to achieve.
And iron is one of the metals that you use.
It is indeed. Obviously, we don't necessarily use wire wool, but you might recognise some of the effects when you see it go in. There, and it's sparking. You just see it sparking.
Yeah, very bright.
Really bright, but there's a sparking effect coming off, and that's what we use iron for. You get that really orangey effect, but it creates sparks.
A nice colour.
It's a lovely colour, isn't it? We've got a mixture of a 50-50 mix of water and ethanol in here, and we've added our metal salt. This is a little bit like a flamethrower, if you like.
This
We're going to spray our mixture across the flame, and we should get a nice puff of the colour. I'm going to do this one just like this, and you just... There we go.
Oh, beautiful.
Really nice. And it's quite wide, isn't it?
Yeah,
rather than just
very
little,
visible.
Yeah.
Very visible.
And also, it's going to keep our Bunsen nice and clean. We could try another colour, can't we? What have we got here? We've got some lithium nitrate, so we'll have a little spray.
And lithium going to give us a...
Should be a red.
A lovely red flame.
Nice colour. Oh, try potassium.
Yeah, the purple colour seems to be...
Good old faithful, isn't it? But you might want to do that with the lights down or something, but it's just another way of showing it, isn't it?
Good demonstration, doesn't it? This is, excellent view of those colours.
Of course, it's absolutely crucial to fireworks. Iron filings, very fine ones. We're just going to hold the spatula over the top and just very gently just allow the iron filings just to roll off. So really, I've just got a little bit like that. Literally just going to hold it. In fact, you can already see it starting to take effect, OK?
It's sparking really well.
Isn't that lovely?
That's lovely.
So we're not clogging the Bunsen up, and that's really important. Right, now let's just look what's happening when the sparkler's burning. We've got that core that's, well over 1,000 degrees. And if we put a bit of paper nearby and catch some of those sparks, we've got sparks hitting the paper, but we're collecting some of the actual dusty particles there, so you can see that actually those hot particles are hitting it. However, if I just touch the core there, the paper's caught fire. So we'll put that into our water there, and it's all to do with the volume and surface area ratio of those particles that are coming off. What mustn't you do once the sparkler's gone out? You mustn't touch it. No, that's right. We normally put it into water.
Right, because it's the rod itself is still very...
The rod itself has got a bigger volume compared to its surface area. So you've got your metal rod, you've got your sparks, and you've got your...
it can be after the sparklers ended sparkling where the damage can be done.
That's right, that's where you can get a lot of injuries. So we have our solution of potassium nitrate, and that's a saturated solution. And literally, it's a case of taking some strips of paper like this, dunking it into our...
Making sure it's really soaked, really soaked.
Because you really want that soaked and really embedded in the paper. And this is the time-consuming bit next, is to dry it out. So I usually use a hairdryer. Right. To demonstrate the fuse, we'll use these ones that we've prepared earlier. OK, so we'll just move that wet one out of the way. Now, all I want you to do is take a lit splint, OK, and just apply it to the end. And just apply that right to the end of your fuse. And as soon as it takes, just move it away. That's it, take it away. Now, what you can see, this is burning across very slowly. And that's exactly what happens in a fuse. It's that fuse principle. But it's not a constant burn. We've got some areas that are burnt quicker than others. So actually in the industry, we wouldn't use that. But it's an old type of fuse, a very simple type of fuse, to show that principle in a classroom. We're going to start with a 50-50 mix of ethanol and hydrogen peroxide. Okay, and we're going to set fire to that mixture. And then we're going to add an additional oxidising agent in the form of potassium manganate 7 or potassium manganate. So, if you can just light that, yep.
And...
Okay, so that's burning. And all we're going to do now is we're going to drop some of our permanganate crystals on top. Okay, and you'll see what happens.
Oh, yeah.
Again,
the lovely purple flashes.
We've got our purple again, but the crackling are tiny little pockets of intense burning, and that's exactly how we create a crackle in a firework. It's intense burn followed by low energy burn, intense burn, low energy burn, exactly as we've just seen there.
That's really interesting, Mark. That's good.
Brilliant. There's this misconception with fireworks in particular that they're too dangerous to do in the classroom, and obviously there are certain things you cannot do in the classroom, but there's quite a lot that you can. I think what we're trying to do today is show some fairly straightforward activities. We've brought out the links to fireworks because there's lots. There's forces, there's the chemistry, there's the flame colours. So there's a lot of stuff that you do generally in schools, but it's just knowing what links to make to fireworks. I think the key to doing any demonstration, not just firework demonstration in the classroom, is don't be afraid. Have the confidence to do it, but you need to practice. Everything that we've shown today is well rehearsed, and in terms of health and safety, to make sure you consult the CLEAPS cards and the guidelines to handling different chemicals, but also to make sure that you carry out a full risk assessment. I've actually bought in some commercial gunpowder here.
That's about the quantity that we need to use.
Really, that would fit on a sort of beer bottle lid, something like that.
Yeah,
okay, it's probably best to do this in a fume cupboard, but obviously we want to be able to see it here. I'm just doing it with a small amount.
Right.
Okay, so I will light my
well back
flame to the end of it, like that.
Oh, nice. Good.
It's lovely, isn't it? Okay. Look, plenty of smoke, and it's that whoosh. And you can talk about...
And a nice purple flame there.
Nice purple flame.
Nice...
So what's that showing us? That's showing us... It's potassium, isn't it?
Some of the metals in there are potassium,
It is. It's potassium nitrate, which is our oxidising agent. Of course, we've got sulphur and we've got carbon in there as well. I've got a drinks carton here with a bit of string on. If you just lift that up, just out of this bowl of water, yeah, and just see what happens.
Oh.
It's spinning.
Spinning round.
OK. This drinks carton has got 4 holes in the corner, and actually most of the water's dribbled out now, but the holes are in the left-hand bottom corner on each face. OK, so the water comes out and creates a little jet.
4 little thrusters, like.
4 little thrusters. This is our pivot point, so we've got a moment, so you can link to sort of turning forces and turning effects. And this is exactly what happens in a Catherine wheel. We've got driving rockets all rotating around a pivot point. And that creates our lovely turning effect. Newton's third law again.
Again, yeah.
Beautiful.
That's lovely.
If you think about a balloon, it's got a narrow neck. We've got a reservoir of air that's going to be released under pressure. We're going to have a blast of air coming out that little neck. It's the rocket principle in action. If you just let that go, it's a bit...
yeah,
just let it go. Off it goes. OK.
Oh, there we go.
Completely out of control. We have no idea where that's going to go. But you can control it by making a very simple line rocket. I'm sure you might have seen something like this.
And we're going to propel along.
That's right. So we've got this really thin nylon wire across the room. We've put a drinking straw on it. So we'll do the same thing again with a balloon. Blow a balloon up.
Another balloon.
We'll stick it on here, but we'll put a clamp over the mouth of the balloon. If I come around here with the tape... Now, one piece of tape should be fine here.
Right.
In fact, I would recommend, if you do this again, maybe try a sausage balloon. OK. Right, let's give it a go, see what happens.
Let's see, and let's release.
Nice one. That's not bad, is it?
Pretty good.
For a first attempt. I've run a little bit of ethanol around the inside of this film pot here.
Inside there.
Just inside, yes.
Right.
I'm keeping the lid on at the moment because I want to keep the vapour in there. I've emptied out the excess liquid, so I've got a mixture of ethanol and air in there. But I've also got 2 tiny holes in the top of this film pot, just there, you can just see. And I'm going to insert the ends of this modified piezoelectric gas lighter. Now, if you look... I press that, you can see it just arcing a bit. And what we're trying to do here, we're trying to ignite the vapour in here. As the vapour burns, it will expand, it will pop off the lid, and we'll actually end up sending something off. And that's what we use when we fire shells, Roman candles. It's this idea of fuels burning, the gas is expanding and pushing something up. I'm just going to thread my electrodes in here. So at arm's length. You ready?
Oh!
And that's how it works.
Well, that made me jump.
That makes you jump. I've got a stoichiometric mixture of oxygen and methane in this half-litre bottle. Our mixture of gases is in there. Now, as we light it, Newton's third law, the gases will expand. We've got our jet of gases coming out here. It's going to create our thrust, sending the bottle that way. So we'll place it on our stand. Now, you can fire this actually directly on the table surface, but I'm going to use a stand, just give me a little bit more directional control. We're going to send it over. Safety screens either side of our rocket. Now, there's two ways of igniting it. If you're a bit nervous and you don't want to put a flame on the end of a stick there, you can use a piezoelectric device like this. This is one I've modified. It's a gas lighter. And we can get a spark.
Just makes a spark.
Just makes a spark at the end. We're going to do it in a slightly more interesting way. We're going to use a flame. In fact, you're going to use a flame.
Oh, dear.
Right? I knew you said
OK,
that.
no,
OK,
that'll be good.
So if you get your eye protection, if you want to light your splint...
Right.
OK. Right, we'll take the lid off the bottle here. After we've bled the gases into the bottle, put a little bit of cling film over the end just to keep the gases in. OK?
Ready?
Yep.
OK.
Nice one. You've got a really gutsy feel there, haven't you? You can really feel the
shockwave as it goes off.
And a beautiful flash coming out the back of it.
And accelerating extremely quickly.
It was, that's right, yes, definitely.
Great. What we're going to show you today are some chemical reactions, but the one thing that they all have in common is they're linked to fireworks. Where do you think you might have seen this before? The main issues that you have in teaching any science, physics and chemistry is to get over those ideas in an exciting, interesting way. So the gas comes out the back, and what goes forward? The rocket. Which famous scientist was it that came up with those laws of motion?
Newton.
Newton, good. The rocket really captured their imagination, and they could see how the ideas of Newton's third law came in. Yeah, that worked. Having seen the pupils' reactions to those experiments, I'm certain I'll be using all of them in my future lessons and linking a lot of science and chemistry to fireworks.
So, girls, you've just seen Mr. Thorley doing the experiments. What do you think?
Really good.
Yeah.
They're exciting.
I like the rocket one.
You like the rocket one? Why do you like the rocket one?
Because it was just more exciting than the others. It was like...
Really unexpected. It was a shock.
Was it loud?
Yeah.
OK. What was it about the sparkler that surprised you?
Well, it wouldn't really, cool down so quickly, I wouldn't have thought. I would have thought it just burned as soon as he touched it, but it didn't.
I have to hand it to Trevor. He's done really well. We came in, we sprung these demonstrations on him and sent him off into a classroom, but his enthusiasm and passion for the subjects has really come across. Well done.